The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. My name is Paul Cusker from Transcat, and I'm going to be your moderator this afternoon. Today we're here for a webinar, All Things Vibration. Joining us on this call is John Bennett, a product and application specialist at Fluke, and also Colin Maxwell, Level 1 Thermal Imaging and Vibration Analysis Sales Specialist with Transcat. John Burnett is going to be taking us through the first part of our webinar today, which is this presentation along with questions, and then we'll have a few words from Colin Maxwell at the end. Anytime during the presentation, you can send us questions to the question box to the right in your webinar controls. If we happen to run out of time before getting all questions, we'll follow up with you offline via email or phone that you provided at the registration. I also wanted to mention that this webinar is being recorded and will be available for viewing through Transcat YouTube channel, and we'll let you know when that is ready to view. At this time, I'm going to turn it over to John for the presentation. Take it away, John.
Okay, Paul, thanks a lot. All right, so I work for Fluke, and I'm a product and application specialist for Fluke. And before coming to Fluke, I spent 12 and a half years with the U.S. Navy operating and maintaining nuclear power plants for the Navy. I watched the Navy transition from run-to-failure maintenance to planned maintenance to condition-based maintenance. I then worked for 18 years for Azima DLI, who is the company that worked with the U.S. Navy developing the vibration automated diagnostic system that is in the Fluke 810 that we'll be talking about today. So as long as everything's going fine, we'll go ahead and start going then. And as Paul said, if you have any questions, go ahead and type them in, and he'll take care of that. So what we're going to be talking about for the next 30, 40 minutes is going to be, I'm going to do an overview of maintenance practices and then the benefits of vibration testing. I will then talk a little bit about the different types and a comparison of 3 different types of vibration methods. We'll talk about the high-end vibration analysis programs, the mainstream vibration testing, and the low-end vibration meter. Then I'll talk a little bit about what is a vibration tester, and we'll introduce and talk a little bit about how the Fluke 810 has made vibration testing easy when, from what I'm going to show you, you'll see that vibration analysis can be a bit complex. Then we'll shift gears and we'll go to a different level of vibration method, which is the vibration screening tool. And we'll talk about how Fluke, with the Fluke 805, has made vibration screening easy, and how they kind of work together, the 805 and 810, how they're different and how they're similar. And then I'll do a comparison and show you some results on the demo machine of the 805 and the 810, a vibration tester and a vibration screener, so you get an idea of what the differences are and the similarities of the results. And then we'll open up the questions at the end. So let me get started. So as I mentioned, I was in the U.S. Navy for 12 and a half years, and I watched the Navy go from run-to-failure maintenance or reactive maintenance to planned maintenance, and then on to condition-based maintenance. And what I saw with the U.S. Navy is at the beginning there was a lot of unplanned downtime, a lot of lost, like any plants in the U.S. or across the world. I visited all over the world visiting customers. A lot of high labor, a lot of high maintenance cost, the overtime, and people sitting around trying to, waiting until a machine fails to fix it. It's not a way to run a plant in today's environment. So to get away from that, a lot of plants have gone to calendar-based maintenance. And calendar-based maintenance, we did a lot of PMs when I was in the Navy. The problem we found is you spend a lot of time scheduling the maintenance. A lot of times we take a machine that was just overhauled, and because the planned maintenance schedule says to overhaul it, we're fixing machines that don't need to be fixed. And as you see in this bathtub curve in the middle, which is a machine casualty rate versus time, you can see that in the middle of this, in normal operation, the casualty rate is very low, and then when you get to the end of the life of a machine, it starts to wear out and then it starts to fail. Well, the problem with a planned maintenance or calendar-based maintenance is we take a machine in the middle of this in normal operation, it's healthy, and we overhaul it, we put in the break-in period where 25% of the machines will break down. So even though this is better than doing nothing, sometimes this can be a lot of money and expenses, and repairing machines don't need to be fixed. So the Navy in the early 80s or mid-80s moved away from calendar-based maintenance into condition-based maintenance, where they would monitor machines using several technologies we'll talk about next, and if the machine is good, leave it alone. So got away from doing PMs when you didn't need to, but yet when you saw a machine was failing, we wanted to know when it was going to go so that we could catch it and get as much life out of the machine, but then fix it before it failed. So different ways of monitoring machines, there's different technologies. Of the technologies, vibration analysis is the biggest bang for the bucks on diagnosing mechanical faults in rotating machinery. We'll spend the next half hour looking at that. Infrared thermography is best for looking for electrical hotspots, but it can also be used to augment or supplement the vibration analysis program in the mechanical vibration, and it also can look for process hotspots. Motor testing it can be done to look for motor faults, ultrasound looking for air leaks, and then oil analysis is used to check the condition of the lubricant, but it can also be used to supplement a vibration program on gearboxes and reciprocating machines where vibration analysis may miss a couple things there. The oil analysis, by looking at the wear particles inside the oil, can help the vibration program. So those are a brief overview of some of the technologies available for condition-based maintenance. So what is the reason for vibration testing? What are the benefits? What are the justifications? Well, there's many of them, and I'm just going to talk about a few here. Some of the biggest would be predictability. It's a big thing to be able to know when a machine is going to fail or when it's going to wear to a point where it's about to fail, not only so you can schedule your repairs, but to have parts. And being able to know that the machine is going to make it for the next 3 or 4 months really helps you when you're trying to schedule your maintenance times. Safety is always a concern, but I think that when you talk to most plants, revenue is probably the biggest one. With vibration analysis, with being able to know the condition of machines, we'll have fewer failures, we'll have fewer outages. There's many cases where we're able to give plants 2 or 3 or even 4 extra days a year for production, and those extra days mean millions of dollars to the bottom line. Increased maintenance intervals, reduced maintenance costs, those are all very important parts where I've seen in some plants where we've taken the life expectancy of a machine from 22 months to 52 months, basically doubling the time that a machine runs before it fails. In the meantime, cutting the maintenance budget in half, from $1.5 or $2 million a year down to $600,000. So and the peace of mind that comes to a program like this, knowing that you're not going to be woke up in the middle of the night with a machine that we have to run in and fix is invaluable. So these are some of the driving reasons for vibration testing. Now, when we look at why we pick vibration for machine health, it's the earliest indicator, and if you look at this simple curve, you'll see that failure of a machine, we can see it months in advance. If you were to go to the right where the failure occurs and move just a few days to the left, you'll see that heat and touch, heat, you can feel the heat on the machine. A little bit before that, audible noise, it will indicate a fault is impending. Before that, infrared thermography, and then months before that we'll find it with vibration. When I was in the Navy, we were tracking faults in rotating machinery 12 to 18 months down the road. We could watch bearings and looseness and imbalance on machines go from slight to moderate, stay at moderate for months, and then it was at the, or even a year, and then you would see the machine go into serious and extreme, and we knew the machine had days left, and we take it down and fix it. So that's an important part of vibration, is knowing when to take a machine down and when it's okay to let it run. So if we were to look at the different types of vibration testing in a plant, I use this machine pyramid to illustrate how if this were all of the machines in the plant, at the top of the pyramid, less than 10% of the machines are very complex with many variables, the production critical machines. In some plants, this may be zero. There might not be that many complex machines with variables. These machines are turbine generators, diesels, paper machines, multi-machines. These are the machines that are very, very critical. They have a lot of variables, and so basically it takes a vibration expert to watch and to trend and to build baselines and to babysit these machines. And these are the machines that you would need analysis software and a data collector and a vibration expert to monitor these machines. But what about the rest of the machines in the plant? 60 or 70% of the machines in a plant can be, they're pretty simple motors, pumps, fans, blowers, compressors, gearboxes, belts, spindles. These are the ones that drive the maintenance manager and his staff crazy, or her staff crazy, because these are the ones that are pretty basic and pretty easy, but even though they're not complex like the ones at the top, they can still shut a plant down. And so the maintenance manager is often not getting a lot of the time for the reliability team, because they're focusing on the critical complex machines that are keeping production going, but these machines are driving the maintenance staff crazy. So these are the ones that we're going to talk about the vibration tester is perfect for, and I'll show you how with the automated diagnostic engine from the U.S. Navy and Azima DLI in the Fluke 810, we can, without having a vibration expert, we can monitor these machines and make the plant run a lot better. At the bottom of the machine pyramid are hundreds of non-vital, expendable throwaway machines, which really aren't worth the time to spend using a vibration tester to monitor, but yet they can still cause problems, and these machines are going to be well suited for a vibration meter that we're going to talk about later. The vibration meter, as you can see, is a good screening tool to look at your hundreds of non-vital, or maybe your vital or critical machines. You can notice the vibration meter can be used in all machines in the machine pyramid, because it can be used to help the reliability team on their critical machines. It can be used to help the maintenance staff with their vital machines, and it can be used on the machines that aren't being monitored down at the bottom. So we'll talk about these two devices, the vibration tester for the mainstream machines and the vibration meter for the low-end machines and the rest of the machine pyramid. Okay, let's talk just real briefly, what is vibration and how does it happen? What are the mechanics of it? You see this simple motor coupled pump. As it rotates around, it makes vibration. That vibration is transmitted from the shaft into the bearing housing, and picked up by this vibration sensor that's on the bearing of the machine. So we would collect data from one or two of the bearings on the motor, one or two bearings on the pump. When you collect data from this sensor that's mounted on the machine, the mechanical vibration is transformed over to a vibration signal, an electronic signal, which is then traveled down the cable to our vibration tester. So once we get it into the vibration tester, then we can do our diagnosis. So let's talk a little bit about the vibration tester. So here you see an image of the Fluke 810, the vibration tester. And when you look at the screen, you'll notice right on the screen, we're not looking at a lot of vibration spectra or squiggly lines. We're looking at an answer. We're looking at the report. And this is something that the Navy planners many years ago asked Azima DLI to do, is to we don't want to look at data, we don't want to look at trends, we want to know what's wrong with the machine and what to do to fix it. So you can see right on the screen, it tells us the problem of the machine and how severe that problem is, and then you'll notice down here repair details. We can then go see what the actual repair recommendation is. We'll show you that in a couple more slides. Across the top there are some connections. We can plug in the triaxial sensor, because if you think about a rotating shaft, as we saw in the earlier slide, when this shaft rotates, it moves in 3 directions. It doesn't just move up and down, it moves up and down and side to side and end to end. So we're going to collect data with a triaxial sensor that allows us to measure all 3 directions at the same time. And this saves a lot of time, gives us a complete picture of what's going on inside the machine, and it saves time. The next connection over would be where we could plug in a single channel sensor if we had some remote sensors on some of our machines and we wanted to download some single channel data. Next to that is a connection for the USB cable to download to the viewer software. In the lower left corner, and we'll show this a little bit more in our presentation, is the viewer software that comes with the 810, and with this viewer software we can store and view and quickly review the data to make sure that the report we see on the screen is valid before we send out a team to go do the work on the machine. And the last connection is the laser tachometer, and you can see that the laser tachometer up in the upper right hand corner, this is a picture of it. That allows us to capture the speed of the rotating shaft to make sure that we have a good input for our vibration system. Over on the right are the buttons and the dials and things to be able to control the 810. Over on the left, we've already talked about that we're going to use this on our common standard types of machines. The 810 has been designed to make vibration analysis simple and easy for the non-expert. Notice that we set this up with 3 easy steps, and over on the right you can see that the first step is setup, where you would go through a machine condition wizard, or sorry, a machine design wizard that would ask simple questions about the setup of the machine. A good example would be like an AC motor, 25 horsepower, 1775 RPM with bearings, and driving a flexible coupling, driving a centrifugal pump with 2 bearings, and the pump impeller is overhung. So pretty basic, simple information. With that information, we can set up the machine, and then step number 2, we're going to measure the data by putting the vibration sensor, as you saw in the earlier picture, and the machine icons would walk you through that process on where to put your sensor on the machine, and on the top or on the side or on the end. And then the last step would be the diagnostic. We'd run past a rule base and give you the answer of the machine condition. So some of the high points, there's very little training with this program, easy to set up, easy to operate, extensive setup, trending, and analysis. An on-site expert is not needed to get machine condition answers. We're going to focus on rotating machinery. The most common faults in rotating machinery are bearings, misalignment, imbalance, and looseness. And so those are the 4 faults that we're going to focus on. Analyzing data over the last 22 years, I see these faults every single day. There's a lot of other faults that you never see, and so we're going to focus on these 4 main faults. Now the vibration tester, we've made it easy. The process, typically you would go through 3 or 4 years of training, learn how to look at these vibration peaks, learn how to trend, how to build baselines. Most of our users don't have the time or the resources to do that, So we take the program developed by the U.S. Navy to make this a simple process. So basically this process mimics the process of an experienced vibration analyst. We do the same steps. This is not a black box. It's an engineering program that's very powerful. It took 25 years to develop and a lot of U.S. dollars to fund and to pay for this development. But you can see that the vibration data on the left, we're going to turn that into the information on the right, and we can show you that process is the same process that a human engineer, a human analyst would follow to get these answers. So I already talked a little bit about this, how the history of the diagnostic engine came from the funding of the U.S. Navy, the longest running and most successful CBM program in the world. They're saving 18 or 19 million dollars a year on the aircraft carriers because of this program. Azima worked with the U.S. Navy for 35 years, and then we took that same vibration analysis program, the methodology, and we put that into the Fluke 810 so that you don't have to be a vibration expert to get vibration results. Over on the right, we talked about the viewer software. The viewer software allows you to quickly scan, review the results, and you can see here's a sample report in the middle of the page on the right. This is a report that comes right out of the software. It shows you a picture of your machine. It gives you the faults, how serious the faults are, and a severity score. That severity score can be exported to a simple Excel template so you can track the severity. And you can see this watching the motor bearing wear go from green to yellow, which is moderate, stay at moderate for months or months, and then ramp up to the orange, which is serious, and then the red to extreme. That's a very useful tool to be able to watch your faults, be able to go from slight to moderate to serious to extreme, and then you know when to take this machine down. You don't have any more life left in it. We just got to take it down and repair it. Okay, so that finishes up with the vibration tester. We'll come back and do a little bit of review at the end, but let's switch gears over to a vibration screening tool, which is the second tool that we're going to talk about. This is the Fluke 805. The purpose of these vibration pens or vibration screening tools are, instead of looking at the vibration spectrum in 3 axes, low range and high range, we're just going to take a quick overall vibration of a machine and the bearing condition just as a simple go-no-go device. So just to tell us whether the machine is good or bad. So we would use this to augment the vibration tester so we can screen out some of the good machines from the bad, especially if you've got hundreds and hundreds of simple machines that we just don't have the time to set up and monitor. So where we talked about earlier, where we take the vibration spectrum and look at it and get the diagnostic results from it, in the vibration meter, the 805, we're just going to get an overall vibration from that. And the way we do that is we simply just take all these vibration peaks that we see in the machine and we add all that energy up into just one number. And so that number is just an indicator of how much vibration is going on this machine. So most of the energy from this vibration would come from the shaft. So if you've got this big heavy shaft rotating at 1800 RPM, it's going to make a lot of vibration. So most of this energy and vibration is coming from the shaft and its components on the shaft. In addition, there is some vibration that we would miss with the overall vibration in the bearings. The bearings have very low energy, and that low energy can be missed. So we use something called crest factor to catch that bearing information. So you see the picture in the lower right, those impacts or spikes are the bearing impacts. And so using the overall vibration will tell us what the shaft vibration is doing, and then the impacting from the crest factor plus will give us an indication of the bearing wear in a machine. So we use these two together in the screening tool. So the screening tool think of it as the nurse. When you go in to see a doctor, before you see the doctor, the nurse is going to take three health parameters to test your general health: your blood pressure, your pulse, your temperature. We do the same thing with a machine using the 805 to screen to see whether the machine is good or bad before we call in the doctor, which is the vibration tester, the 810. So the three parameters that we're going to measure is in the top of this display. You'll see there's the bearing vibration information. Below that, overall vibration, the machine overall health, and then we also take temperature. So with these three parameters, we have a pretty good idea of the general health of the machine, on whether that machine is good or whether we need to call in the big guns to take a look at this machine. So let's quickly look over some of the problems. Talking to our customers before we developed the 805, we said, what kind of things do you like and dislike with the vibration pens in the market? So some of the things that we heard were, the number one was the numbers didn't mean a lot of things. So they see this number of 0.06, and then it goes to 0.07, and then 0.08. They don't know what's good or what's bad. So we're going to show you how in the 805 we have a straightforward 4-level severity scale that tells you whether that number is bad and what to do about it. A lot of programs don't have enough information. They just use overall vibration. And as I showed you earlier, the 805 is going to give you 3 sets of parameters: overall vibration, bearing condition, and temperature, to give you a complete solution. Many vibration pens on the market, depending on how you hold the pen, how much pressure, what angle, all gives you different answers. In the 805, we have an innovative sensor design, force sensor and tip angle, which compensates for this and means that your angle and pressure is minimized. A lot of the vibration pens are made of cheap, lightweight plastic. You drop it and break it. Well, the Fluke brand is very rugged. All Fluke instruments are very, very rugged. They're made out of tough, heavy plastic. When you hold them, they feel very, very solid and well balanced in your hand. A lot of the vibration pens were difficult. You had to add a lot of information, and I'll show you how it's very easy to set up the 805. Basically, all you're going to give it is the name of the machine, tell it which of 37 categories. We already have the overall vibration stored in the machine, so it already knows what overall levels to use. And the green light, you'll notice this green light down at the bottom. When you press the 805 into the bearing of a machine, once you've given enough force, the green light comes on to tell you that you've had enough force. You hold it there for half a second, and the light goes out, and the test is done. So it takes all the guesswork out of getting a good, complete test with enough pressure. The last complaint was that the vibration pens were manual. You had a number you couldn't do anything with. In the 805, we put that number into an Excel spreadsheet in the Excel template that comes with the 805, and we can compare to ISO standards. So let's go through the connections that are on the 810. One connection is an external sensor. This optional external sensor allows you that if you can't get into tight places with the 805 because the way the pointer is on the end of the device, you can put an ICP single channel accelerometer plug into the bottom, and this would allow you to put it anywhere on the machine you'd want. You can hook headsets. A lot of people have walked on their plants with a screwdriver to the ear or a stethoscope. This allows you to listen to your machine, and that way maybe you can hear some high frequency noise. When you're greasing the bearing, you know when to stop greasing. And the last is to export the data to your PC so you can store, trend, and evaluate the results. I talked about 37 different machine categories. We've partnered with an expert in the vibration field with the 805, same as we did with the Zima DLI on the 810. So with the 805, we have overall vibration levels from 37 different machine categories, and that way you can select one of these categories and then the 805 will know what vibration levels to tell you whether that machine is good or bad. So here's how the screening works. You'll notice that we're going to collect data, three different parameters: high frequency vibration for bearings, low frequency for overall vibration and temperature. You'll notice that in the bearing region, the top, there is a severity scale, and that's your crest factor or your bearing severity number. If you look down at the bottom, you can see the scale. 0 to 5 is good, 6 to 10 is satisfactory, 11 to 15 is unsatisfactory, greater than 15 is unacceptable. So that gives you a number so that you know as you go along. We know that 6 is going to pop up here as satisfactory. When it gets to 12, it's unsatisfactory. So it's more than just a number. It tells you whether it's good or bad. The same thing with the overall vibration. When you set up the machine with one of the 37 categories, then it knows what vibration levels for overall vibration should be good, satisfactory, unsatisfactory, or unacceptable for your particular category of machine. So then you would store the information in your PC. You could then trend those using our graph, our Excel template. In this example, you can see that along the bottom, your x-axis is time. Over on the left is overall vibration, and over on the right is crest factor plus. And you can see that over on the left, the light blue, you see the light blue line trending up. That's telling me that my overall vibration is getting bad on this machine. But if you'll notice along the bottom, the dark blue, my bearings and crest factor hasn't changed. So if we follow the overall vibration ramping up, if you look over to the right, there's two different scales. One is the ISO rating that goes from good to satisfactory to unacceptable. And you'll see the ISO table down at the bottom. The ISO 10816-1 is a general industry-wide ISO standard, and it's for all types of rotating machinery. So it's not very specific to your particular type of machine, but it's a general industry standard. Where over on the right of that, you'll see the Fluke overall severity scale based on the 37 machine categories, much more specific, and notice that it trends from good to unsatisfactory to unacceptable as our overall vibration increases. So basically, let's kind of talk about when and why you would use each of these devices and what the results would look like. So here's the 805 on a little fan that we use as a simulator, and the 810. So the 805 is the vibration meter. It's a screening tool. And you can see that when there was no fault, the screening tool found the bearings were good and the overall vibration was good, showing the machine was good. When we imbalanced the fan, notice that the bearings were still good, but the overall vibration is unacceptable. So that tells us when a machine is good or bad, and that's the purpose of the 805, is to screen and tell us if a machine is good or bad. Then we would bring in the 810. The 810 would take 3 axes of vibration data on the machine, and it would tell us when there's no fault, that no fault is found. But where the 805 told us that it was unacceptable, but we didn't know what the problem was, you can see that the 810 gives us the answer. It says that we have fan imbalance, it's extreme, and then if we go look at the details, it'll tell us to balance the fan. So as one last screen to kind of overview the two instruments, you can see that the 805 is used for screening to tell us what the vibration levels are, if they're good or they're bad. So we're going to collect overall vibration and crest factor plus for bearings. We're going to trend these numbers over time, and then we're going to use ISO standards and the 37 categories to tell whether the machine is good or bad. If you go up to a bunch of machines and you see good, 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 bad, then we would need to bring in the 810. The 810 would give us the answer. So the 810 is going to collect 3 axes, low range and high range, of high resolution spectral data. It's then going to convert that over to a report that's going to tell you the exact fault, how bad the fault is, and what to do to fix it. And we can take the severity score and trend that number over time. So instead of trending a number, an overall vibration, we're trending the severity score of the fault, and that gives us an idea of watching that fault as it gets to a point where we got to take it down and fix it. So that brings us to the end. So as an overview, the 810 and the 805. So the 805 is a vibration meter, and it's used for the frontline maintenance mechanic teams as a screening tool to fit in their existing rounds, gives them go, no-go maintenance decisions, trend the readings over time to know when to call in a consultant or to call in the big guns, the vibration tester. The vibration tester at the bottom, maintenance troubleshooters who need answers about the specific fault and the severities. These answers are available without extensive setup, trending, analysis, or an on-site expert, and it allows us to get the information we need to generate work orders and take machines down to do the work. Okay, so now I'll open this up to questions and let Paul take, let's see if we have any questions, Paul.
Sure. As a reminder, thank you, John, by the way, for this great presentation. If you do have any questions, please submit them in the question box to the right in your webinar controls. We do have a couple questions so far, so I'll go through those, and then hopefully we'll get a couple more as you answer these. So the first one is, how does the ISO IST value compare to Mills peak to peak?
Okay, so the ISO level is, and I have a small picture here. It's usually in the ISO level is in velocity, but you can use this in mills are in displacement, and there is a conversion, and the 805 can measure and show number levels in either acceleration, velocity, or displacement. So you can view or screen any one of those three numbers, and so I guess the best answer to the question is, even though the ISO table is in velocity, which is inches per second, that number can be converted over to displacement number, which would be a Mills peak to peak.
Okay, great. We've had a few more questions come in, so we'll go to the next question. Is the spectral data available for the 810 as well?
It is. So inside the 810, even though we take the data, the spectral data, and we go through the process and give you the answer, the data is still available in the 810, and it's also available in the viewer software. So what I typically recommend a customer to do is to see the results on the screen of the 810 and maybe do a quick look at the data out in the field if you know what you're looking at. But then in the viewer software, we can view all three axes, low range and high range, and it's much easier on your PC to be able to quickly scan the data and look for change, while out on the field, the 810, the screen's a little bit small. So even though you can do some viewing out in the field, I would recommend to do most of it back at your PC. Okay?
Okay. Can you balance with the 810?
Not yet, but we do have that in our plan because right now the 810 will tell you whether your machine is imbalanced and you have bad bearings and it's misaligned or looseness. It has the hardware and the tools, and so that's one of the development projects we're looking for in the near future, is to add balancing to the 810. So the answer is not right now, but we're looking to add that as a program. The nice thing is, when that is finished, it isn't something that you have to buy more hardware or send your 810 in, or even worse, buy a new device, the balancing will be a firmware upgrade, and so it's something that we can do probably right over the internet, and you wouldn't, or send you a CD, you wouldn't have to send the equipment in or buy new equipment.
Okay, next question is, how often do I need to go and make a diagnosis of a machine?
Typically, there's a lot of different parameters, but I've been doing this for, for about over 20 years. Most machines would be monthly. Now, there's sometimes you've got machines that just don't run very often, and quarterly would be okay. So what we typically recommend is we would like to see it monthly. Quarterly is the outside. So based on the frequency of how long your machine is running, how critical a machine, you would somewhere between monthly and quarterly.
Okay. Is there any way to use the 810 to perform bump tests to determine natural frequency?
No, unfortunately, the 810, even though it is a vibration data collector, and many vibration data collectors on the market can do bump testing, we have designed the 810 to be easy to use, and in order to be easy to use, we had to not allow some functions, and one of them is doing a bump test, because that takes a highly trained vibration person to be able to know how to do a bump test. And so the 810, because this is designed to be simple and easy so that anybody without vibration experience can still use it, bump test is not something we're going to do.
Okay, next one is, can we export to another format other than PDF with the 810?
Not right now. You can export your severity scale to an Excel template. We are considering exporting to maybe to a Word report, or maybe even exporting into other formats, but that hasn't been thoroughly discussed or evaluated or approved, but that is something that we may do, and I just don't know when or when that'll happen. Okay,
we have time for one more, and if we didn't get to one of your questions, we will be sure to address it with you via email or via phone, whichever way you registered. So don't worry, we will answer your question. Do you have to set up the bearing database?
Oh, that's a good question. No, because the diagnostic engine inside the 810 has a uses pattern recognition, and by using this pattern recognition, we can follow the bearing wear that occurs in all roller type bearings. So we use something called the 9 stages of bearing wear. As the bearing progresses from slight to moderate to serious to extreme, those patterns have all been saved, and those rules are all within the 810. So by following that pattern, we can identify roller bearings without having to know the bearings or the bearing database, because the problem we found in the earlier days of doing bearing analysis is you can, if you had the bearing tables, you could find the exact bearing frequencies, but the problem is not everybody knows what bearings are inside their machine. So if you don't know the bearings, then a bearing database or bearing tables aren't going to do you any good. So instead, we follow the patterns that all roller bearings follow, and that way we can tell you what bearings you have going in your machine without knowing what bearings are in there.
Okay, we have one more quick follow-up to the bump question from a couple questions ago. Since we can't do a bump test, I assume we can't do startup or transitional readings, i.e. time wave readings?
That's right. That's right. No, this device is set up to it does collect the raw time waveform, and then it converts it to the frequency, and all of the rules are written in frequency spectrum analysis. And so this is not a real-time analyzer or it's not even a vibration analyzer. So it's not a tool for a vibration expert to be able to trend and do any analysis. For something like that, there's a lot of other companies that build those, but again, to make this easy, we've designed this device not to do some of the more complicated functions or features. We're just going to give an answer, and we're going to show you how to what's wrong with your machine. But it's not an analysis tool. It's not a trending or a real-time analyzer.
Great. That's all the time for questions that we have today. But as I said, there are a number of questions I know that didn't get answered yet, but we will be sure to reach out to you either right after this, or we'll email you or call you with the answers to those questions. And I know there were a couple of questions in terms of price and calibration. At this time, I'd like to turn it over to Colin Maxwell, who's our vibration specialist in-house here at Transcat, to tell you a little bit about what we can do for you in terms of vibration, in terms of calibration and costing and so forth. So,
okay.
Go ahead, Colin.
Thank you, Paul. Just a few quick things that I wanted to tell you about. I know that there were questions regarding calibration. First of all, there were questions, for example, that were asking how often should it be calibrated. That is an issue that is entirely up to the quality process at your company. That is something that we do not determine for you. There are some general recommendations that we can make, but until we know more about the quality process in there, we would want to go into a more deeper discussion than that. The second is that we do want to bring up something else, is that, and this is something that does happen frequently at Transcat, we do have items that may sit on the shelf for a while. Transcat does have the option for people of doing what is called a stock calibration, which means that we will calibrate it before you get it. So that is something that if you do want that included, you certainly can request that when you request a quote from us. As far as the pricing is concerned, the 805, the list price on the 805 was last time that I checked, was roughly $1,800. For the 810, we're looking at just under $8,500. However, I do recommend people look at both of them. If they are looking at a comprehensive vibration analysis program, this really does cover about 90% of the situations that you're going to run into, short of having accelerometers permanently mounted and everything. So I do strongly urge you to, if you do have questions regarding the Fluke vibration pieces, we do, number one, we have them available in stock. If we do not have them in stock, we can get a hold of them quickly and even arrange to have them drop shipped to you. If you require demos, if you would like to have somebody come out and demonstrate it, that is certainly not a problem. I have actually worked with John, and he has actually gone on at least a couple of demos that I've set up and answered every question that anyone could conceivably have about the 805 and the 810. So if there are any additional questions, you can certainly direct those to us. For those of you whose questions we didn't respond to, as Paul mentioned, we will be following up with you. Do not worry.
Yep. And on that last slide, you can see Colin's direct extension here at Transcat. You can get a hold of him by dialing 800-828-1470, extension 3520, or you can email him at cmaxwell@transcat.com. And if you didn't have a chance to write those down now, they will be included in the presentation when we do send that out. So keep an eye out for an email over the next couple of days when we are able to get out the presentation to you. It'll also be available on YouTube to view again if you'd like to, or if you have colleagues that weren't able to make it today, that'll be available all the time for viewing. We want to thank you for attending, and thank you, John, for this very informative presentation. We hope that you found it informative as well. And as I said, we'll get answers to those questions out to you as soon as we can. So thank you for attending, and we look forward to seeing you in future webinars from Transcat. Thanks so much.
Thank you.